Thank you for the introduction. In this talk, I will present MobileInsight, a new methodology on your phones to let your phones see through the black box mobile networks. The 4G and 3G cellular networks are very critical for mobile users. Today, they are the only deployed large-scale wide area wireless infrastructure that offers mobile data service anywhere, anytime. Their operations affect every mobile users and online services. However, although we use 3G and 4G mobile network every day, we keep suffering from network failures, bad performance, backward drains, security loopholes, without knowing why and how. When we all know why we use certain phrases, we wonder why I cannot use data even if I have a single cost. We may even wonder why I cannot move to the faster 4G network I got stuck in the 2G network. We may sometimes even why my phone screen is so quickly I didn't use any data, I didn't use any mobile applications. This list simply goes longer and longer. The reason is that all these problems can be related to the underlying cellular network operations, including the radio resource application, mobility management, data service quality, traffic scheduling, power control, and security mechanisms. But these cellular operations are main codes. They are realized in multiple cellular-specific signaling protocols, ranging from the physical layer protocols, link layer protocols, and the MAC protocol, video link control, and PC protocols, and radio resource control protocols, mobility management, data center management protocols. But different from Internet's TCP/IP stack, on the phone side, all these cellular-specific signaling protocols are implemented inside the hardware chipset, and then their operations are not exposed to the software space. Mobile apps have very limited access to their outbound kind of operations through the legacy mechanisms such as anchor checks. So we ask a very simple question. Can we have open access to runtime cellular operations? We want both data and analytics of these dynamic cellular protocol behaviors as software space. We want fine-grained cellular operation. We want to cover all cellular protocols. If you have this capability, we could not only quickly resolve the problem we have seen before, but we can also stimulate many new research opportunities in the cellular world. In the end of the talk, I will give you some examples of what type of new research we can stimulate. But let's focus on this question first. Can we do that? Actually, this is not a simple task. Because to achieve it, we basically need a tool that should satisfy at least 5 features. First, it should collect the information from all cellular protocols, ranging from the lowest physical layer to the high data center management layer. For each protocol, we need to get this fine-grained cellular protocol information, including its runtime states, including its configuration parameters, including its operation logics. We should run runtime analysis of these protocols. And to cover wide areas of the mobile network, we want to do both data extraction and this analytics at scale, anywhere, anytime. All these features should be achieved and ready deployed inside our off-the-shelf phones, without extra hardware support, without upgrading our phone models. Unfortunately, no existing approach can achieve all of these features. This is our focus. In this talk, we will present our solution, MobileInsight. MobileInsight is a mobile app for our off-the-shelf phones. It satisfies all these features and provide us open access to runtime fine-grained cellular information about this specific network. It has been publicly released as a clinical and it has now been downloaded by 36 research institutes. So in the rest of the talk, I will talk about how MobileInsight works. We will evaluate MobileInsight in different aspects, and I will show you how MobileInsight will enable new research opportunities in the cellular world, and I will conclude this work. Let's first look at how MobileInsight works at high level. MobileInsight basically runs as a user-based application on our off-the-shelf phones, and it has 3 components: monitor, analyzers, and index. It first facilitates closest over-the-air cellular messages from the hardware chipset to the software. These messages were exchanged between our phone and network, and it covers a wide range of cellular protocols, from the lowest physical layer to the highest physical management layer. They carry fine-grained information, including the states and parameters. With this information, MobileInsight Researchers can leverage information to have a more accurate understanding of the cellular operations, and developers can use them to build new applications. So we next introduce each component. The first task we should do is to expose this raw overlay cellular messages from the hardware to software. This is the model. Of course, this is not easy. As you can note, today the ordinary in-device games without chip, we all know that for Android APIs, we only have a very subset of this basic cellular information. That's because the cellular chipset only exposes coarse-grained cellular information from this hardware to software to the user interface layers, and Android APIs simply encapsulate this information and only provide a further subset of information. Definitely, we cannot rely on these mechanisms to achieve our goal. So how do we do it? Our solution is to enable a new side channel across the software-hardware boundaries inside the phone. We observe that many cellular chipsets support external diagnostic mode, which means that when you connect a phone to an external laptop through the USB, the hardware chipset can expose this raw cellular messages to the external laptop through this USB port. MobileInsight leverages this feature, but emulates the external developer inside the phone. To do so, basically we adapt this in-device diagnostic mode. We send special I/O control commands to this diagnostic mode, and redirect all the cellular information from the USB port to our users. With this raw cellular messages, now we can pass this message and get the rich cellular information, and then we can further do this analytics. Of course, there are many problems in passing cellular messages, such as how can we handle this rich message format, how can we handle dependency between different messages, and how can we optimize the passing speed for the real-time demand. For this problem, you can find the answers in our papers. We find more details there. With the cellular messages, the next task we will do is to perform the runtime cellular analytics of the cellular protocol behaviors. For each cellular protocol, we will uncover two dimensions of behaviors. On the device side, we will first track device-side quantity dynamics. We will also infer network-side operation logics. So let's look at each dimension. The first task is to track each protocol's device-side state dynamics. This includes the current protocol state, the state transition events, and why the state transition happens. For example, before the video resource control, this basically means we would know the video connectivity status between the mobile device and base station, and whether the phone would enter the power saving mode or not. Here we show 40 state machines of this power saving mode and tennis status. For mobility management, this basically means the migration features to the mobile network, and for data session management protocols, this basically means data session activity and the request status. To track these dynamics, our key observation is that the device-side state-machine dynamics are regulated by cellular standards. These state machines have been standardized, so it allows us to perform a two-phase approach. We first derive a reference state machine out of the standards. Basically, it includes each state and state transition conditions as a function of the runtime cellular messages, which includes parameters, message types, and some timers. Then, at runtime, since we already know we already get this runtime cellular messages from our motor, we can feed these runtime messages to this reference machine. This way, we can get exactly your current state transitions, and this transition conditions. This is actually the ground truth of WebPMC. Besides the device-side quantity dynamics, MobileInsight can also infer some network-side operation logic, which basically means the network comparison and the algorithm policy to determine which parameters you should use for protocol and which method you send and delete. For example, in switching and routing network, each base station has handle decision logic, which tells you under what condition you should move to the 2G network and what condition you should move to the 4G network. This will affect your data performance. However, different from device-side process dynamics, we face two challenges in inferring this decision logic. First, this decision logic varies between different network operators. It's not standardized at all. We don't have a reference point. Second, this operation logic are not visible by standard mobile devices. So how can we infer? Our key observation is that the operation logic is not arbitrary in reality. Actually, it has two very important features. First, a state represents the management control command issued by that word, or handle command, which asks you to monitor neighbor sales or do a handoff. The same transition can be modeled as sequence of single strand measurements issued by the MobileCom. So this way, you can, although this is logic customizable, this state machine like to remain stable, so we can load this internal structure. The second observation is that it's also impacted because to have a proper handleization, the business simply needs to know the feedback from device. It simply to know the device signal strength. With these two features, MobileInsight learns this logic by performing online state machine inference. So our solution is actually inspired by a query-driven state machine memory algorithm from the AI area. We model the operations as well as the machine and infer by pairing this control commands and this measurement reports. So we'll use a simple example to show how it works basically, but for detail algorithm can check our paper. So first, there are two steps. First, for each analog track, we will track each sample sequence of this single message, including 19 commands and measurement reports. So we opt this one and we can partially recover all this state machine. Because we can use each command as state and the sequence between two commands as a conditions. So in this way, we can recover multiple state machines from different sequences. Then we move to the next step. Basically, we merge different state machines. We merge the same state and we merge the state transitions. Of course, there are many other problems. For example, how can handle the conflict between the states and how can handle the conflict of state transitions between the same states. For the details, you can check our papers. MobileInsight has provided very simple and extensible APIs for mobile apps. So here we show how we use this one to track security portable states. So all you do is clear a monitor, declare our built-in portable analyzer for switching portable users control, bind them to the monitor and simply run it, and then you have this runtime portable state information. In our latest version, we also provide a new set of API with simple semantics. If you're interested, you can check our website. So now let's quickly summarize the evaluation of mobile. We evaluate mobile and before aspect coverage, performance, accuracy, and system overhead. MobileInsight has covered a wide range of tech models. We have validated that MobileInsight can support mobile OS including Android and iOS. We have validated it can support Qualcomm chipset, Media chipset, and Intel XMS chipset series. For details verification, you can check our paper with details. In our current public version, we have supported Bluetooth Android phones with Qualcomm chipsets. In the next few months, we will release iOS version and support for other set of hardware chipsets. MobileInsight has covered a wide range of 3G for signal metrics and some 4G physical layer and linear metrics. To validate, we have performed 13-month user study over 30 phones and 8 US and Chinese sample operators, which tracks, we have tracked 250 byte rate signal metrics, which carries 72 million signal metrics. So when we have validated all the signal metrics can be successfully tracked. For detailed share package, you can read our paper. This data set has been released public. You are free to download. You can use this one for your research. So MobileInsight can largely meet this real-time demand. We have tested this how fast MobileInsight parse and analyze each set of metrics. So this figure shows this CTF or programmatic processing time through three high-end SSD phones, medium-end Samsung S5 phones, and low-end LTE. For all these phones, we can finish 99% of the message processing and analyzing within 0.8 milliseconds. The worst case we observe is 33 milliseconds. So it largely meets this real-time demands. MobileInsight performs accurate quality data analysis. It achieves the same quality truth as the de facto Qualcomm XDM model for the using this source. For the network side, operation logic, we don't have the quantum, but we can use the cross validation to predict the accuracy of our input. Instead logic, we find this accuracy ranges from 87% to 90%. So in a cheap output, MobileInsight have very reasonable system overhead. The CPU ranges from 1% to 7%. Its memory is roughly 7 megabytes. Its energy is roughly 1150 milliwatt extra power. So with MobileInsight, we can do many research. In our work, we have leveraged MobileInsight to develop several new applications, including network video resolutions, local detection, performance boost. All these applications can be achieved by training policy data mix and infra-optic logic. For details of our findings, you can check our paper. We can also leverage one to enable this more intelligent roaming between different operators and even mobile configuration detection by network operators. more false, this runtime cellular information can give the mobile phones the access that however, the access that becomes mobile basic analytics. We can do this one to understand what's the total current cellular portals and perform new solutions to refine and define programs. We can use this one to detect the low-level security threats such as jamming and denial of service attacks. We can, of course, we can use this one to do the healthcare, mobile web, and mobile video performance application improve. So in conclusion, we believe that the utilized open access to cellular operations is beneficial. It's beneficial to more users, or